Brilliant!
Perceptive!
Welcome to Super! Welcome to Super! Good day, partner!
What a beautiful life, partner. So we are going to talk about physics. Hey there, viewers! Fasten your seatbelt, enjoy, and listen.
So today we are going to talk about the kinematics in one dimension. So what is kinematics?
Kinematics is a branch of dynamics that deals about the aspect of motion on a certain object.
So take note, it is only the motion of a certain object. So the kinematics
Motion alone.
Kinematics to one dimension contains the concept of the constant velocity and acceleration of motion. So when we're going to talk about the velocity, it is the quickness of motion of a certain object. While
Acceleration motion is the rate of the speed of a moving object that changes over time. Okay, so to formally introduce the concept of kinematics in 1D, hey there, viewers!
watch and learn.
Does it ring a bell to you, Kasuperb? So, if P1 starts from rest and accelerates uniformly over a time of 66.64 seconds for a distance of 100 meters, what is the acceleration of P1?
So in that situation, we can conceptualize the diagram like this. So if this is if this is P1, this is the starting point, is the zero velocity or the V1, and a distance of 100 meters in 66.54 seconds.
Right there, partner.
And this is the finish line. So the question is, we are going to find the acceleration motion. So,
Time for simplify. 0 meters per second multiplied by 66.54 second would result to
0.
0. Added by
1 half.
1 half
1 half of A.
1 half of A, and 66.54 seconds squared, that would be
That would be 4,427.57 seconds square. Take note of the unit.
so next is
1 half of 4,427.51 seconds
that would be.
would result to 2,213.79.
So again, 2,213.79 seconds squared came from one half of 4,427.57 seconds squared.
So
Next.
since we are going to find acceleration, so we are going to divide both party or both terms by 2,213.79 in order to cancel out and
To remain here, our acceleration alone.
Oh,
How much would be our acceleration?
So 100 meters divided by 2,213.79 square second would result to 0.045 meter per second square. So partner, therefore, P1 has the acceleration of
0.045 meters per second squared.
So this is it. And now we are going to illustrate the graphical analysis of position, acceleration, velocity versus time graph. So first, we have the position versus time graph. Partner,
Okay,
let me
so
enlighten this illustration.
for our x, let us have our time. And for our y-axis, let us have our distance. So, we are going now to plot the graph. So, for 20 seconds, it covers a distance of 13.31 meters.
So
So,
approximately,
probably it would be located here. So, if you're going to ask us, why 13.31 seconds?
so,
Kindly explain for our Kasuperbs partner.
so in 100 meters, or in 66.54 seconds rather, it covers a distance of 100 meters. So 100 divided by 66.54, that would result to 0.67 meters. So if we are going to multiply it by 20 seconds, it will result to 13.31 seconds.
So, very well said, partner. And for 40 seconds, it covers a distance of 21.62 seconds.
Correction.
Meters.
Correction, partner, that is 26.67.
I'm sorry, partner. 26 point. So,
It will be
60
here.
here.
Meters, rather. 26.62 meters.
And for our 66.65
54.
54. What is happening to me, partner?
So really, physics is very hard. Even us, we're going sometimes,
It literally blown our
Your
minds.
mind, yes.
So, for 66.54 seconds, it covers 100 meters. If we're going to connect the dots,
so it simply means that in 0 seconds, it cover up with 0 meters. So we have constant increasing until 100 meters.
so next in line, mga ka-superb, is our acceleration versus time graph. Explain, partner.
So again, in our x-axis, we still have the time, and in our y-axis, we still have the acceleration. So in plotting the acceleration versus time graph, we're going to look back our position versus time graph.
Yes.
So from 0 meters to 20 seconds, it's very clear that it is constant. So constant is like this. And from our 20 seconds up to our 66.54 seconds, it's very clear that it is constant yet
Increasing.
So this is now the new phase of our acceleration versus time graph. And lastly, we have our velocity versus time graph.
Okay, so mga ka-superb, again, for our x-axis, we have our time, and for our y-axis, we have our velocity. So, just like what we did earlier, we are going to base our velocity versus time graph on our position versus time graph. And
Take note.
take note, the velocity versus time graph is just the same on what we had on our acceleration versus time graph. So,
So since they are the same partners, we can plot it easily. So we have constant and then constant
increasing. So,
this is it about our graphical analysis in motion on position, acceleration, velocity versus time graph. So compare the difference.
so this is all for today, mga ka-super. If you want to learn more, we are going to leave seat works that you are going to answer. So, let us call this a day, partner.
A day of
A day at the races. So, this is it, mga ka-super. Let us call it a day.
brilliant,
Perceptive
super!